Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we've got another informative topic. Here it is. OCS-I relay modules. Well, OCS-I is a very popular family of expansion and remote I/O for use with the Horner OCS all-in-one controllers. And there's a variety of different reasons you might use relay outputs to control a portion of your application, and today we're going to explore that. We're not only going to look at all the different relay modules that are available for OCS-I, but we're going to talk about relays versus solid state and what might be some of the I's that need to be dotted and the T's that need to be crossed anytime you're using a relay output in any control system. Okay, let's go ahead and get started. We're going to start by doing a quick review of the OCS-I family. We'll talk relays versus solid state outputs. We'll compare all of the different relay modules for the OCS-I family. We'll talk about relay wiring considerations. And what about transient suppression? What's the issue there? And then we're going to take a look at the new DQM602 module, which is available early next month. So you'll want the full scoop on that particular product. All right, here we go. So what is OCS-I? We're going to do a quick review of that family and then move on to today's topic. So OCS-I is a family of expansion and remote I/O that will really complement any OCS-based all-in-one controller control system. It does well if you've got a rather large system where you have dozens or even hundreds of I/O points. It does well if you just need to add a little bit more I/O, maybe to a micro OCS simple application as well. It interfaces quite well with all OCS models over the C-scan port. And if you're using one of the new micro OCS models, it just connects with a standard patch cable on both ends. If you're using one of our controller families that utilize a terminal block for the C-scan port, then you can either very easily make your own RJ45 to open terminal style cable, or you can buy one pre-assembled from Horner. Okay, when you're designing an OCS-I system, the first thing you need to do is you need to select a base module. What does the base module do? Well, the base module is the one that interfaces with the OCS through that RJ45 connection. Now, we have two bases available. We have the CNX100 model, which is just a base. It has no built-in I/O of its own. And then we have the CNX116, which not only acts as the base, but also has a very flexible complement of I/O points. Now, if you're using the CNX100, you can add up to 8 I/O modules to that particular base. If you're using the CNX116, you can only add 7, and that's because the CNX116 has some I/O of its own. All right, now, again, a maximum of a total of 8 I/O modules per base, or per stack if you want to call it that, and a maximum of 16 I/O bases per network. So you can get rather large systems, as you can see. Okay, now we have quite a list of available I/O modules these days for OCS-I. It's grown quite substantially since its release, and I have them kind of summarized here on this particular slide. Now today, we're going to be focusing on the particular I/O modules that feature relays. So that's what we'll be diving into next. Before we look at the different relay modules available for OCS-I, let's talk about relay outputs versus solid state outputs. Really, what are the differences there? Well, let's start with the pros for relays. So generally with relays, you can support higher loads, loads that have more current requirements. So as an example, a typical relay output module might have 2 amp per point capability, whereas, a rather beefy solid state output, at least from an automation standpoint, would have about a 0.5 amp load capacity. Now, of course, in some of the mobile markets, they have some very sizable solid state outputs in those particular markets, but we're talking about general automation here. Another advantage of relays, it can handle both DC loads and AC loads, whereas typically Most solid state outputs that are used today in automation are DC only. However, these pros are not without their cons. Relays are mechanical devices and they do wear out. So whether it's 100,000 transitions or 1,000,000 transitions or some number in between, they do wear out. Also, because of the nature of the way relays switch loads on and off, because of those mechanical contacts, and because of the fact that sometimes those loads can be substantial, relays generally will require more transient suppression in those applications. So definitely something to consider with relays from a pro and con standpoint. All right, next we're going to finally dive into the 3 different options we have with the OCS-I family for relay output modules, and we will compare and contrast those. So if you know you have some relay requirements for your application, but you're not sure which module to choose, by the end of this presentation, you should have that all figured out. Okay, so we've got the DIQ512, which is a mixed I/O module, so it has DC inputs in addition to the relay outputs. That's available. We have our DQM502. That's a 4-channel high current relay output module. And then we have the new DQM602, which we're releasing early in February, which offers a little bit higher density than either of the 2 options with 8 channels at 2 amps each. Okay, let's look at the details of each of these 3 modules. All right, starting with the DIQ512. So we've got the wiring on the bottom left there of the inputs. Okay, this is the only module that has relays that also has DC inputs, and we're showing you the DC input wiring there in the lower left-hand corner. The basic summary though is you have 4 DC in and 4 relay out, and one of the advantages of this particular module is the fact that you have that mix. So you might be able to save a module in your stack. If maybe, otherwise you would use a separate output module and a separate input module, that would be 2 modules. But if you can squeeze in 4 or less DC inputs along with your relay outputs in your system, you could save a slot. Now let's take a look at the relays themselves here with the DIQ512. All right, we're talking a maximum load of 3 amps per output. Okay, so 3 amps max per channel, per relay. Also, each relay has its own common. So if you're using all 120 volt AC for the output loads, for instance, or all 24 volt DC, you will have to jumper the wiring from common to common on the module. However, if you're looking to mix and match AC and DC in different voltages, then actually it can be quite a convenience to have those separate commons for each of the relay outputs. So that is the HE959 DIQ512. All right, now let's get into what we call our high current relay output module, and that is the DQM502. So it is higher current than the other relay modules we offer, and we'll talk about the details on that shortly. It also can drive large loads, and because it is also 1 relay per common, it also gives you the ability to mix and match between AC, DC, and different voltages. Okay, so that is another advantage there. And unlike the DIQ512, this module can also support AC voltages up to 240 volts AC, whereas the previous module we talked about was limited to 120 volts AC. Okay, looking at the specs and the wiring, you can see the details there on the screen. Again, you have 5 amps per relay, so that's a higher current capability. However, you can't have more than 10 amps per module. Why is that when all the commons are isolated from each other? Well, that's just because of the potential heat that could be generated by that much current flowing through the module all at the same time. So because of UL regulations and just, good practices in terms of the amount of heat that can be generated from current loads of that size, that's why we have the limitation of no more than 10 amps per module, even though you could have as many as 5 amps per relay. Now we're getting to the new relay module that we're just releasing, or releasing it in February, fairly early in the month we expect. Okay, now to use this module, you will require a newer version of Seascape that supports this module. So if you're using Seascape 10, you'll need to use Seascape 10.1, which will be released either at the same time or a little bit earlier than the relay card. And then if you're using Seascape 9.9 still, you'll need to get Service Pack 14, which won't be available probably until March. So if you are using 9.9 and you don't want to upgrade to 10, you will have to wait a little bit longer to start using this module. But the summary of the module capabilities really are that it is a little bit higher density than what you see with our other modules, at least from a relay standpoint. Now, looking at the specifications and the wiring, you can see from a maximum load standpoint, we're looking at 2 amps. Okay, so a maximum load of 2 amps per relay. And because 4 relays share the same common, there's also a limitation of 5 amps per common. So keep that in mind as well, as relays 1 through 4 are on the first common and relays 5 through 8 are on the second common. Okay, the other thing I will mention is, like the DQM502, the DQM602 also supports 240 volts AC. So something to keep in mind there. Now that we've kind of reviewed the 3 different relay modules available for OCS-I let's talk about some wiring considerations. And we're going to start with the field wiring terminals that are available on this module. Okay, now with OCS-I in general, there are a couple different remote terminals that are available, or field terminals that are available. There's a 6-pin and a 4-pin. Now, because this is a relay module, and typically relays have slightly higher loads than say analog points or input channels, those sorts of things, this particular module has a 4-pin removable terminal. All the positions are labeled, so you'll know, which wire goes where. And you can use anywhere from 16 to 24 gauge wire. And one thing to keep in mind, which we'll talk about on the next slide, is that there's really no sense in using larger wire than you need. Sometimes we think about, oh gosh, we've got a 3 amp load or a 5 amp load. We really need to crank up that wire size, but that's not necessarily the case. And again, we'll talk about that in a second. And then these terminal blocks are all removable, and we've got some screwdriver specifications there for the task of either ejecting the terminal, which I'll demonstrate later in the program, or in just loosening a wire that has previously been inserted. Now let's get to that discussion about wire size. Let's make sure we make it easy. Okay, there's no point in using larger wire than is required. Now, keep in mind, based on the specifications I reviewed with you over the past few minutes, there really is not going to be any particular terminal on any of these relay modules that is rated to have more than 5 amps per conductor. So, if you want to use a larger load than that, you're going to have to use an external relay on a DIN rail and drive it with a solid state output or something. So there is no terminal that is specified to get more than 5 amps of current. So why use wire that's excessively larger than that? If you could use 18 gauge wiring comfortably here, and it's rated for 6 amps. You could also use 16 if you'd be more comfortable with that. So again, the bottom line is don't use larger wiring than you need to. And the other thing is, with OCS-I ferrules can really make the job nice and easy. And we would recommend that you use ferrules that have a 10 millimeter long barrel for the best experience. Okay. Now let's talk about transient suppression, because that's something that with small DC loads, we don't really think about much because it's usually not much of an issue. But if you're talking about large inductive loads especially, and the fact that we've got mechanical contacts doing the switching, you have a much higher potential of having some harmful transients that are generated when one of these inductive loads, especially the larger ones, are switched. You get voltage spikes, current spikes, electromagnetic interference, all those things have the potential for harm. And the larger the load, the larger the potential for harm. And again, whether when you're talking about components that are the biggest violators, if you will, from the standpoint of inductive loads, you're probably talking about motors or solenoids, those sorts of things. Now, what types of harm are we talking about that could happen? Well, certainly, you could have premature relay contact failure. Okay, that's absolutely something that could occur. You could also have spurious resets in your system. Maybe there's a component somewhere in your system that's a little more sensitive to this sort of EMI than other components are, and maybe it'll experience a reset when it sees this transient, occasionally. Or maybe it could even be damaged. So those possibilities for harm definitely exist. So what can you do about it? Well, there are a variety of ways you can mitigate this sort of occurrence, but it's going to vary. The strategy you're going to use is going to vary by the type of load that you have. So examples, of mitigation strategies would include adding components like snubbers, diodes, and spark quenchers. What should I use on which load? All those sorts of things. Well, you need to kind of do some research there. That's kind of beyond the scope of this particular video. But you can often find recommendations in the documentation for some actuator devices that are kind of a known offender. Okay, whether it's a white paper on the manufacturer's website or whether it's built into the user documentation, do a little bit of research. You should be able to find the information you're looking for. And if you've got a manufacturer of large actuators like large solenoids or motor starters or those sorts of things, they often offer suppression devices that kind of match their components that they sell. So that's another reason why it's a great choice to check the manufacturer of the actuator, because again, they're aware of the issue and it's just a matter of physics really, and they probably have components that they're going to recommend to you or maybe even sell to you. So again, it's a little bit beyond the scope of this discussion in terms of the very specifics, but keep aware that transient suppression when you're using relays, especially if you're switching large inductive loads, is definitely something you need to be concerned about. All right, to wrap up our topic for today, we're going to take a look at that new DQM602 relay module we've been talking about. All right, let's take a quick look at the new DQM602 8-channel relay output module from Horner. Now, we really don't do unboxings on this channel, but I guess this is kind of an unboxing. You can see this is pretty much how OCS-I modules are packaged in this, relatively compact cardboard box. Everything's pre-assembled. You've got the front here where you've got all your removable terminal blocks. They're already assembled. You also have your backplane connector, which is also assembled. Now, this we'll need to remove, okay, before we actually assemble the module. Okay, so if I'm going to add this to a stack, what I need to do is I need to get this backplane connector onto the DIN rail. Okay, I snapped it in place, and then I need to slide it into the stack. Now, if I'm assembling half a dozen modules, I'm probably going to pull all the backplane connectors off of all the modules and then assemble the complete backplane assembly at one time. But anyway, to add one on the back of the stack, that's what you do, what I just showed you there. Okay, now to add it to the stack, it's really a matter of just, basically using the DIN rail as a fulcrum, the top rail of the DIN rail as a fulcrum, and snapping it into place. Of course, there's nothing unique about anything I've done here that's unique to this particular relay module. I just thought I'd kind of demonstrate it for you again. Here on the left, we've got our I/O base, okay, with our two RJ45 connectors. The first one goes to the OCS. The second one, if this is the one and only base in the system, or if it's the last base in the system, you'll need to use a terminator on the second port, and those are available as accessories from Horner. Now, with any Horner OCS-I module, if you want to pull the removable terminal blocks, it's a matter of using a long enough screwdriver to reach in and then pry against this orange piece here. Okay, and then up pops all the terminal blocks at once, where they can either be fully removed, as necessary, and of course when you're done, you can snap them back in. Okay. And if you ever need to take a module off the stack, whether it's on the end or in the middle or whatever, it looks very similar, but really what we're doing is we're inserting the screwdriver, and instead of pulling against this orange tab here, there's a silver tab at the bottom, so we're pushing the other direction or going the other direction on that, and that allows any module to be removed, whether it's on the end of the stack or the middle of the stack or wherever it is, it really doesn't matter. Okay, now in terms of the field wiring, lots of ways to do field wiring with this product. Generally, I like to use wiring with ferrules. Generally, I would use either 16 or 18 gauge, usually 18, unless there's some particular reason why it needs to be 16. And with a analog card, you know, I probably would use even smaller wiring if necessary, because a lot of times you're using, 22 gauge or 20 gauge twisted pair for your analog wiring, usually shielded, not always. But this is this is a relay output module we're talking about. So again, just use a wire. If you use a ferrule, it makes it even easier. You don't need a tool even to insert the wire, okay, if you use a ferrule. If you do want to take the wire out after the fact, no problem. You just use your small screwdriver there, push down on this orange lever and pull up, and away it goes. So very simple on the field wiring as well. So again, this was a quick look at the new DQM602 relay module. A lot of what I showed you applies to all OCS-I modules, of course, except for the fact that this particular module is an 8-channel relay output card where you have effectively 8 relay connections here and 2 different commons, C1 and C2. All right, this is the portion of the program where I remind you we're here every Tuesday at 2 o'clock, whether we're fully live or whether we're pre-recorded. We've always got somebody standing by to answer your questions. And if you're watching one of our videos on replay, like a lot of you do, give us those comments and questions in the comment section, and we'll be more than happy to get back to you quickly. Okay, we've got a big event coming up very soon, and that is the launch of the new OCS-360 cloud service from Horner. And we have the public launch webinar coming up on Monday, February 3rd at 3 p.m. Eastern Standard Time. We've got the link to register for that webinar on the screen. Now, this won't be shown on YouTube. This is going to be shown on in a private event that you have to sign up for. So I would highly encourage you to do that right away. Don't forget, sign up for an OCS training course, or maybe even 2. In 2025, we offer both a basic and an advanced course. And the feedback we get from our customers is they really like the training that folks like Nate Beachy and Tim Brandt put on for you. So sign up today. Okay, lots of trade shows in 2025 in which you can see Horner products and Horner people in person, and we'd love to see you at one of those. So freeze frame this slide and put a date in your calendar. All right, lots of ways to interact with Horner online at hornerautomation.com, also on our YouTube channel, as well as LinkedIn. Okay, now beyond the launch webinar for the OCS-360 cloud service that's happened on Monday, February 3rd, we're also going to have an OCS-360 related live stream topic every single week in February, and it's even going to bleed over into March for at least 1 week and maybe more. So you can learn about OCS-360 and hear about how you can sign up and those sorts of things in the launch webinar, and then every week for the month of February, you can learn even more. So you'll definitely not want to miss that. Okay, if you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live and every time we post a new video. Okay, all right, so until next week, let's all get together. Actually, let's do this instead. Until next week, let's all get out there and do some good.